Number 2 is going to look familiar. We've done these type of problems before. The only difference is that now we are applying them to hydrates. So remember that in the previous problems, what we did was I told you that it was a certain amount M and a certain amount Z, and you were able to figure out what the moles were here and the moles were here, so you could figure out what the formula was. Well, now we're going to do the same type of thing, except that instead of looking at M and Z, we're going to give you MZ, and instead we are going to be interested in how much water is in that MZ. And so what you're really doing is you're trying to figure out what X and Y are here so that you can figure out the moles of MZ and the moles of the water that are there. And as soon as you know how much this is and how much this is, then you know the formula of the hydrate. So this problem is done just like the ones we did before. It's a percentage problem. So because it's a percentage problem, I'm going to keep my life easy, and I'm going to assume that I have 100 grams of this compound. And apparently it is ZnSO4 and water. So apparently I have 100 grams of ZnSO4 .X H2O, and that's, I suppose, keeping things real here, Y H2O, so it's the same number that's there. So all I got to do is figure out what X and Y are. According to the information, I gave you 56.2% ZnSO4. So that would be 56.2 grams of ZnSO4. And then if we subtractify that from 100, you should end up with 43.8 grams of water, because again, those guys are going to go together to make the 100 grams that I assumed. Pick any number you want, but I can do that math in my head without a calculator. All right, so anyway, now all we have to do is turn these into moles. Well, water's easy. That's 1 mole per 18 grams. All right, but zinc sulfate, we're going to have to look at the periodic table and figure out what zinc sulfate weighs. So here's zinc, sulfur, and oxygen, and there is going to be one of those, and 4 of those within the formula. So if you add all of that up, then you're going to end up with a molar mass for zinc sulfate, if I've got my math right, to be 1 mole per 161.5 grams or so, depending on where you rounded. So I do my math on that, and I get 0.348 moles of the zinc sulfate. And then when I do the math for the water, I end up with an answer of 2.43 moles of the water. So now what I do is I set this up so that I have my zinc sulfate part, that's X, and I have my water part, that's Y, except I now have those numbers. My zinc sulfate is no longer X, it's my 0.348 that I got from here, yoink. And my water is no longer Y, my water is the 243 I got from here. But what did we learn in the last part? If you have these two things like this, you want them to be whole numbers. So what do? You divide by the smallest number, which is in this case the 0.348, and you divide this by 0.348. And when you do that, this just becomes 1. And 243 divided by the 348 that is there is, if I've got my math right, a 7. So if that's the case, because it's a 7-to-1 ratio, then you write the hydrated compound like this, ZnSO4, and then put a star or an asterisk or a dot, and then put 7H2O, and that's the formula for the zinc sulfate heptahydrate that's there. So apparently it's a 7 for the zinc.